Um, Good afternoon all, and thank you for joining us today for the CPD event. My name is Lino Vieira, and I form part of the CIBSE Southwest Committee. I'm joined by my fellow committee member, Evelina Suzara, and our presenter, Matthew Edis from SES. Broadly speaking, today's CPD will cover the energy performance certificates, SAP SBEM calculations, and a lot more background information. Providing this expert knowledge for us today is Matthew Edis. Matthew is the Director of Sustainability Construction Services, a firm that he founded in 2008. They provide sustainability services within the built environment. Matthew's background includes working on sites for main contractors like Langley Aurora. He studied at the university to be a structural engineer. He had the honor to work with Max Fordham as a building services engineer. He worked for a multidisciplinary team, BDP, as the head of sustainability. He's qualified in BREEAM, Home Quality Mark, SKA, and CEEQAL assessor. He has been working with on material life cycle embodied carbon assessments for the last 7 years. And on top of all of this, he is a CIBSE Chartered Building Services Engineer, low carbon consultant, SAP qualified, can lodge EPCs, and I'm told he makes a great cup of tea. I'll take you up on that one, Matt. Just quickly before I hand over, if all attendees can raise any questions they have in the Teams chat function, there will be a 15-minute slot at the end of the presentation where we try to answer all of these for you guys. And without any further delay, I hand over to our presenter, Matt. Thank you.
Thank you very much. Yeah, I'll I'll just share my screen. Hopefully that will work. Share screen. Window. Share. Can everybody see that? Okay. Excuse me.
Yeah, I think so.
Yeah. Can everyone see?
Yeah.
Yeah. Everyone see it.
Maybe.
Okay?
Yeah. Just maybe full screen option.
Escape. So send share screen window. Sorry, I've just had to jump on another computer. My camera
Yeah.
this morning, so if I've actually jumped onto my kids' computer, so apologies. Is it okay just to use the one that I was just using?
Yeah, I think let's go with that one. Just to mention that the presentation will be shared after the CPD.
Right. Okay. Great. Okay. Right. So keep an eye on the time. Demystifying EPCs, SAPs, and SBEM. Matthew Edis, Sustainable Construction Services. So yeah, I'm the one pretending to know what I'm talking about today. So it's apologies. It's going to be a little bit dry, though. I mean, the subject is a little bit dry in the sense because it's sort of legislative requirements and compliance and that sort of stuff. So yeah, it's not going to be a wild ride, but certainly I'll try and make it as interesting as I can. So the subjects we're going to do is abbreviations. So some of the acronyms sort of people sort of ask about, want to know about. It's useful to start there. Then quick brief history of PARTO and EPCs. Going to go on to building regs and trading standards. If you're wondering why I've written trading standards out there, I'll explain in a minute. Then about modeling levels. So when we use SAP and when do we use SBEM and that sort of stuff. PARTO, about the 5 criterion, notional building, some of the sort of the basics about that, both the non-domestic and then domestic, and then on to EPCs, and maybe if you've got time, a little bit in the future. So it's I'm going to try and rattle through as much of this as I can and keep it sort of simple, but if it's aimed at a fairly simplistic level, so apologies if you're a super duper modeler, you're probably not going to learn a huge amount today. But if you're anything other than that, hopefully you're going to gain some value into listening and as I explain this sort of stuff. So this is your agenda. Okay. So abbreviations. Let's start with the basics. Keep it really simple. SAP. So what does SAP stand for? It's a standard assessment procedure. It's a tool for calculating sort of energy calculations for domestic dwellings. It's been around long before Part L morphed into the current state that it currently is, so it's been around for years and years. RDSAP is a reduced data SAP, so that's something that you use. It's the same methodology as normal SAP, but it's really aimed at existing buildings because it's got less data. NCM, so people hear about the NCM, the National Calculation Methodology. When Part L changed into the way it is today, it was effectively, it's the rules for how you want to try and quantify energy use in buildings for regulatory compliance. Bit of a mouthful. SBEM, Simplified Building Energy Model. That's the it's the calculation of the non-domestic buildings, and it's the Part L it's basically the basis on which Part L and EPCs are calculated. So it's the simplified building energy model. So it's a way of sort of defining energy use in a sort of quantified and sort of consistent manner. Sometimes people here. Sorry, say again.
The slides. It's just staying on slide number 1. Did you want them to move forward?
Apologies. Can you, so you can't see what I can see now? Can you see this?
Yeah, I can see that now. You've changed the slides.
I'll stay on this then. Apologies. Apologies if it's. Hang on, I'll just shove that over. The joys of technology. I'll move that as quick as I can. Okay, yeah. So here we go. So RDSAP, NTM, National Calculation Methodology, SBEM, Simplified Building Energy Model, ISBEM. The acronyms go on. DS, Dynamic Simulations, so sort of a much more interactive, sexy, super duper version of modeling, which is different to the SBEM, but also can be used in Part L. DYS, so Design Summer Year, can get confused with DS, Dynamic Simulation, and is to do with sort of overheating. And then there's TYR, which is the test reference year as well. So you've got that. The BRUCL, quite a lot of people talk about BRUCLs. If you're not sure what that is, it's the Building Regulations UK Part L. It's the document you get out when you do the energy calcs, and it's the standard sort of response that you're showing how you're complying against the criteria in Part L. EPCs, most people talk about it, but just it's probably obvious, but energy performance certificates. And MEMS, minimum energy efficiency standard, is the thing that landlords worry about when it comes to EPCs. So if I mention some of these and acronyms, then that's kind of where it's come from. Okay. History of Part L. History, Part L is the conservation of fuel and power. So we never used to be interested in CO2 back in the 70s. I mean, it came around first in the 50s, but it's sort of something looking like what we've got today. But 76, anybody who's sort of good in their history or sort of aware of sort of fuel and history of fuel is when there was the oil crisis in the 1970s. So around that time, we started to get a bit more focused on energy use. And over time, you could see that there's an incremental sort of improvement in some of these walls and roof view values. But then there's a kind of line in the sand where you can see that nothing very much changed, sort of 2006, 10, 13. So why was that? That was really when energy modeling came in. So why did we get into energy modeling? So building regs never had this sort of energy calcs. The big thing that came in was the Energy Performance of Buildings Directive. It's a European Union requirement, and it said that all member states had to have a way of addressing emissions in their buildings, and to try and respond to things like the Kyoto Protocol about CO2, and obviously we've had the Paris Climate Agreement subsequent down the line. So it was really that thinking. And at the time, best part 20 years ago, that was sort of pretty innovative. And so all countries had to do something about it. And we'd only just released our 2002 building regs when this all sort of kicked off. So the targets were that we're going to reduce emissions by 25% every 3 years. we were going to get down to sort of net zero by 2016 to 2018, and refurbishments were going to be as tough as new build. That was the aim, and that was the sort of the great sort of hope that would be there. The reality is somewhat different. 2006, sort of, there was a 25% reduction on 2002, but then it was only sort of 8 to 10 in 2006, 8 to 10 again in 2010, and it's taken until 2021 to be able to get 30% down. But that's really, in overall terms, we're only sort of half of what we were in 2006. So 2002 is an interesting one because we defined our performance against 2002 building regulations. So the idea of it was that you would build an energy model. It would be based on the regulations that were applicable at the time of 2002, so very much elemental. You sort of what your U value was, what your U values were, what the efficiency of equipment and boilers and lighting was at that time, and therefore we were going to use that as the line in the sand. That's adjusted in more recent regs, but that was the original idea, and then we put some reduction factors. So the idea was we were always sort of trying to move it on and move it forward. That's why, even though these numbers add up more than 50%, I would suggest we're only kind of 50% better than when we were years ago. Okay, so that's the potted history. I don't want to labour it too long, but okay, building regs and training standards. Why training standards? So Part L, everybody's sort of fairly familiar. Building regs, thou shalt do certain things. You've got to get it through building control officer, and Part L is part of the checks of that. However, EPCs are not actually a regulatory requirement for building regulations. They're technically a trading standards document. EPCs give you your lovely A to E or A to F energy label, but it's very much like your fridge or your cooker or equipment like that you get for electrical goods. So therefore, it actually comes under trading standards. Now, the reality is that I've never, in the time I've been qualified, I've never had any contact with trading standards. And the only time that anybody asks for them is when the build control officer asks for them. So as part of the sort of mandatory requirement at the end. But technically, it's the people who govern EPCs are trading standards. Okay, so where else do you use Part L calculations? You tend to hear them being used in planning applications, BREEAM, home quality mark, that sort of thing. So what you're doing there is you're producing calculations that are standardized and consistent. And that's really what the key to the use of SBEM or SAP, that's really what we're trying to get there. And the reason that the councils like it is because it gives you a standardized methodology in which to follow. So you often get in planning applications, thou shalt have energy targets and 15% or 20% or 10% better than building regs. Really, policy is whether they're interested in the energy use or the CO2. It's policy driving towards CO2, but different local authorities have different ways. Sometimes it's energy, sometimes it's CO2, sometimes it's both, and it is the devil is in the detail. And one of the challenges we have as consultants is the fact that when you do an application, you have to read the policy in detail, because how they use the Part L calcs is different. Same with BREEAM. BREEAM uses it, and home quality marks. So that's giving you an energy performance. And what's interesting about BREEAM, for instance, is that you get a result there that is actually interested in information that gets produced in the BRUCL document, the Part L output sheet, which actually captures a couple of different things. It captures not just CO2 emission, but it also captures the amount of energy required to service the building. So as in, what's my base requirement for heating, lighting, that sort of stuff. But it also then takes into consideration and does another calculation as well as those two, which is how efficient am I delivering my energy that I need to service my building. So a combination of both how much energy I need and the efficiency of the equipment. So if I've got a boiler at 90% efficient, then the question will be resulting in the sort of net performance of both the demand and utilization of the performance of the equipment. What Part L shouldn't be used for is to predict energy use, which sounds daft because everything I'm talking about here is talking about energy use. Everything I'm here is talking about CO2 emission. But when I say energy use, it also means CO2. You shouldn't be using it, which sounds daft because everything we're doing is putting in information into the building, into a model about our building. So we're putting, when we do these energy models, we take all the geometry, we put the size of the windows, we put the equipment that we're using, and then we run and we click run, and it spits out numbers in kilowatt hours and in kilograms of CO2. And it's normally based against per meter squared. But what it does do is to make it standardized, is that it uses agreed and standardized occupancy profiles. So you've got no control over your ability to say when it's being run and when it's not being run. So when an office space is occupied 9 to 5, Monday to Friday, it will define occupancy levels, and it will be not possible to adjust it. Similarly, in terms of when you're putting in, there are some basic controls that you can set within the calculation methodology, but you can't actually say, well, this is going to turn on and turn off at certain times, because what it's going to require is a comparative tool. So therefore, you can't adjust. You can say what your control strategy is, but you can't say exactly that I'm going to turn it off at 2 p.m. and turn it back on at 3 p.m. As a result, it's producing a calculation that is a comparative tool. And lots of people miss this. Oh, what's the Part L output? Oh, and they start to equate it to their bills and the energy use for their bill. It shouldn't be, it can't be, and it must not be. However, people do. More so as well, the calculations ignore certain other loads. It's only interested in what is defined as process loads. It doesn't include for things like cooking, doesn't include lifts, external lighting, doesn't include anything that you plug in, so your computers, your laptop, your printer, your hi-fi, anything like that. Doesn't include any of those. It's only the things, it only looks at the things that you require to function and to run a building, so to make it a space that can be occupied. It does not use predicted energy. Okay. Modeling levels. So when you use which model? So level 1, you don't tend to hear this much, but actually behind the scenes, this is what the levels are. So in building regs and in sort of the national calculation methodology, level 1 is RDSAP. So what do? You use a simple SAP calculation methodology. The idea is that it's different from a new build, which is level 2. The reason level 2 is different from level 1 is I can tell you what the build-up of a new build wall is because an architect or contractor has designed it, and I've got a build-up, and I can go and talk to the manufacturers. If I'm trying to do a SAP on a existing building, I'm not allowed to. Joe Bloggs, whose house it is, they won't be very happy if you drill through the wall start bashing a hammer with a hammer to get the holes in it to find out what it's made of. So there's the sort of simplified assumptions about build-ups and fabric performance, and that can be based on age and what have you. So it's a simplified. The levels 3, 4, and 5 are all about non-domestic buildings. Slightly frustratingly in the UK, unlike say in Scandinavian countries and other countries, when we do our calculations, we're only interested in individual dwellings. So the SAP is only run per dwelling, which means if you've got an apartment block, you have to run the calculation on each individual apartment, and everything outside of that dwelling space is technically a non-domestic building. So what it means is you can't sort of look at it at a strategic building-wide, building fabric basis. You can only look at the dwelling zone. So that means that you get site darkness with SAP if your corridors are heated. Well, sorry, if they're unheated, then you just look at the elemental minimum standards of any wall that is in that corridor that may be exposed to outside. But if it's a heated corridor, then you have to actually do an SBEM calculation or a dynamic simulation calculation at level 3, 4, or 5. That often gets ignored by most building control officers in my experience, but certainly places like London now, where you get asked specifically that question for London plan counts, then building control officers in London are asking for those counts. So it's a area, and it comes down to the interpretation of building control officer. And I think that's also quite key, just to mention, building these calculations, if they're being used for Part L, like all building control, is subject to a bit of interpretation. There are minimum standards that must be complied with, like you have to do the energy model using the right software. But it's the same thing. If there's a reason why your fabric isn't particularly good in one area, or there's a reason, or the calculation is doing something daft, it is okay for building control to agree with you a variation in the results. So the Bruckle may have a red in it because there's a red mark against something saying that hasn't passed. If there's a logical reason and you can argue the case of building control, they can accept it. That's not the same with EPCs. EPCs are a black and white scenario. You follow the rules, you put the information in, you spit out the answer. Even if the answer is daft, if it's advantageous to you or detrimental to you, those are the rules, and that's what you've got to follow for EPCs. So that's the fundamental difference between Part L and EPCs. And this level 3, 4, and 5, so just keeping an eye on the time, sort of rattling on. So level 3 is SBEM, so really simple stuff, like I've only got 3 spaces. I've got a little tobacconist, and I've got a front room, I've got a main sort of sales space, and then a little storage cupboard behind, and maybe a toilet, something like that. You can use it for that. SBEM level 4, you've got most buildings, but level 5 covers sort of anything that's more sort of sexy, I guess. Anything with an atrium, dynamic blinds, those sort of things that are going to be a bit more interactive and iterative on the model performance, and therefore you're allowed to use a dynamic simulation. When the reason you can use, interestingly, you can use dynamic simulation also to cover levels 4 and 3. Why would you do that? 2 reasons. One, because as a modeler, then you're probably, the rules for level 5 are slightly different to level 3 and 4, and it's easier to only have to remember one set of rules rather than having to keep on jumping between and do 7 rules and make errors. But the other is that you would generally want to use a level 5 because you get a slightly better result. The dynamic simulation tends to produce a better answer than the SBEM answer because it's a better way of mimicking your actual building performance. Whether that's right or wrong, I've long since given up trying to argue the case, but it is just a statement of fact. And also, different softwares are slightly different in their performance. TAS produces an ever so slightly better result than IES. Not massive, but it's marginal. And on one project, we actually had it where, in the end, because it was such a fine line and the BREEAM was such an important thing for the outstanding rating, they actually ran the TAS model for BREEAM compliance and actually ran the IES model because it was the one that the contractors team wanted to run with and use that for building control submission and EPC lodgement. So that's a bit of an extreme case, but it does show you that even within the software there is slight variation. And this is the table you follow. You can find it in the conventions and documents that are associated with Part L, but you follow this. But if in doubt, you go to level 5 if it's non-domestic. Okay, 5 criterion. Keep on rattling through. Part L, there's 5 criterion. One is focused on target emission rate. So you build a notional, in whatever software you're using, you build the software, you put in the data about your systems, your equipment, your usage types. So is it an office, is it a classroom, etc. And it produces a couple of calculations. In the domestic it produces 3, in the non-domestic it produces 2, and it's an emission rate, so the CO2, and a primary energy rate, the sort of energy use of the building. And generally all these softwares and all these calculations, what they're doing is producing energy calcs, and then once you've got your energy result, you then apply CO2 factors, and then that is applied. And the biggest single change from between the current regulations and the previous versions of regulations, all the previous old versions of regulations, the CO2 emission for electricity used to be sort of 2.5 times the CO2 emission rate for the same amount of energy used compared to gas. Gas doesn't change, and electricity does over time as we green the grid, and the number for electricity is much more comparable to gas now. So when you start to apply COPs, coefficients of performance, the sort of energy in to energy out, when you're using heat pumps and stuff, and you're, for every 1 kilowatt of energy you use, you get 2.5 kilowatts of useful energy, that sort of thing. You can see that everything is going towards electric, and that's a good thing anyway, because it means we're not burning CO2, fossil fuels that once released, and we can't really get back into the ground. So criterion 1 is setting these ratings, and in SAP, the fabric energy efficiency is an absolute pain in the bottom, and it's really, really very difficult. I'll come on to that more in the notional as domestic in a minute. Criterion 2 is minimum elemental levels, so that's sort of minimum U values for walls, roofs, windows, that sort of thing, and equipment, so heating systems, lighting systems. Criterion over 3 is for overheating, and with that, what you do is you need to make sure, even if you're air conditioning a space, you still need to check your overheating performance, and it really focuses on glazing. And the idea of that is, even if you have aircon, you're trying to minimize the need for aircon, even if you do have aircon. It's really focused on the amount of glass in your facade. Energy models, target is basically at the end of the building, you have to rerun all your counts and show that what you said you were going to build and the CO2 emissions are still being achieved and complied with. And criterion 5 is all the things like logbooks, how do we use and build. When you do the notional building, or what are you doing when you're building these models? What you do is you have to zone your space. So when you're building the energy model, you define zones, you define their usage, and therefore the notional building, your actual building, has a how long do I have to run my bits of kit and what my heat losses are, depending on the glazing and the fabric. What's interesting is on here, you've got on the right hand side, you've got a depth. This meeting room is a single meeting room, but there's mentioning of 6 meters here. The model was really interested in knowing about the depth of the space, because what they're doing is wherever you're close to a window, it's assuming that there's going to be the potential for daylight linked lighting controls, and therefore the amount of lighting that you would use would be less. So that's why it's interested in the depth, and you define each zone separately. So the calculation is done on a room by room basis, effectively. So you can't steal from Peter to give to Paul. So you can't have all glazing on the top floor and no glazing on the lower floors. It just won't like it. The top floor will get too hot and lose too much heat, and the other ones won't get enough light. So you've got to look at it room by room, and that's an easy mistake for project teams to not realize. There are other notional requirements. So things like the amount of glazing, I've mentioned glazing a few times now. There's a definition of the amount of glazing that is assumed in the notional building. So most things are like for like comparison between the notional building and your building, but one of them that isn't necessary is glazing. So what it does is there's, you can see here that there's a sort of targets about glazing, that it's 40% of the exposed facade. But what does that really mean in visual terms? It means if the top here is your actual building, what it's going to do is going to create in the notional building a glazing that is 40% of that facade, and it's going to apply that in just to every single space. So it's instead of it being actual windows, it's assuming a standardized amount of glazing. What it's trying to do really in simple terms is avoid something like this. Floor to ceiling glass everywhere. It's really trying to push you away. And why is that? In really simple terms, glass loses, the U value of glass might be circa 2, the wall might be 0.2, so therefore you're going to lose 10 times as much heat through a piece of glass as you do a piece of wall. So where do people tend to get things wrong? If this is a space and this is a room, you've got someone in there, and this is the amount, this is trying to reflect the amount of light that comes in. Lots of architects I work with tell me that they need full floor-to-ceiling glass to be able to get good daylight. It's not true. That's not physics. If you've got a window that's got a if Move back up. If you've got a window where there's a windowsill, this is how the daylight level changes. It's pretty much the same. It's more interested in where the top of the glass is rather than the bottom. So you get amount of light being bounced back. So actually being able to have a good window that is designed to be towards the top of the room is actually all you need to get good light. This is a room based on a plan view rather than a section that we had before, and I've tried to sort of draw it sort of something similar. Apologies, the image hasn't come out wonderfully, but you can imagine the light sort of tends to weigh at the back. If you though have punched windows rather than full width windows, the amount of light doesn't actually change massively. What does all this mean? It's not very sexy, doesn't look like a great architecturally, but to get a good performance in Part L or in EPCs, you want windows that no more than 40% and tend to look a bit like this, so that you're only actually getting evenly spaced windows across and nice windows to the top of the space. As I say, architecturally not very sexy. Here's some of the stuff about the notional building. You basically, I was saying that if you, the notional building is actually got tougher U values than the Part L minimums. So if you follow the Part L minimums, you won't pass. If you follow the notional figures, you probably won't pass, because despite whatever the documentation says, and yes, as you follow all this, you'll pass, the reality is there's so many little caveats and limitations and conditions and what ifs in the software that if you just follow these figures, you still won't pass. So you have to go even further than these. And it's certainly when it comes to glazing, that is a definite area to attack if you possibly can. The other thing to remember is that the way that different buildings use energy is different. So you're not interested in the total amount of CO2 or the total amount of energy. You're interested in your performance relative to the notional building. So this is different building types. You can see this is a sports hall, and it's got a massively greater amount of energy use compared to, say, a school or a retail or an office. But what you're actually interested in is this, the relative performances. So in a sports hall, this is hot water. So massive amount of hot water assumed in a sports hall. Is that true? Probably not. Most people I know, when they go to the gym, they don't have a shower, they come home and have a shower. Or when I was at school, I don't think anybody showered in our school after PE, because if you did, then someone would nick your clothes. So you didn't have a shower. But these are built in theoreticals, so it's a comparative performance. Whereas a school might be more about heating, retail is going to be heavily dominated by lighting. That also means, therefore, actually U values in building fabric aren't actually that critical for a retail to comply. And an office may be a bit of a breakdown in the mix. I personally think that the hot water in the office is a bit of an overestimation, but I'm not in control of the results. So these notional build, when you're modeling, you've got to think about this, you've got to think about the equipment efficiencies. So what it means is there's more than one way to skin a cat. And if you're working on a project and it's, say, a school project, when you come to the next one and say it's a retail, the rules and the guidance of where you should focus to get compliance differ depending on what your building type is and what the usage profiles are. So there's not one rule that fits all. It's not a case of always hitting your U values and the equipment achieving certain performances. It may be that in this example of the sports hall, and actual fact, focusing on the hot water will be one of the most critical things in compliance, whereas retail will be more about the lighting. Notional buildings, the domestic, same sort of thing. You build a notional building, you build your actual building, you compare the two. But the absolute killer in there's two things that are absolute killers in the domestic. One is the window. Now in the building regs document, you won't actually find this, but there's a G value. So G value, in simple terms, is the amount of solar gain that comes through the window. So it's the amount of energy that is beneficial solar gain. So if I've got a G value of 0.63, what that's saying is 63% of all the viable available solar energy coming through the glass will come into my space and offset my demand for mechanical heating. So it also is asking for a U value of 1.2. So anybody who's an expert on glazing will know that that's a pretty hard ask, and there's almost there's almost no one who builds glazing to that level of performance. One of the reasons for that is to get the good U values. What do? You make U values. There's cost associated with glass and the thickness of glass. There's cost associated with the frame. So one of the cleverest ways to make a U value better on glass is to make it more reflective. Make it more reflective. The heat, radiant heat, doesn't go out of the space. It gets reflected back in. The downside is it means it's also more reflective when you when the solar energy is coming in. So you're immediately behind the curve compared to the notional building because it's getting all this inverted commas free heat. What makes it worse is when you're working on projects in, I don't know, in the south, anywhere in the south of the country, and especially in the southeast, that what you've also got is major issues with overheating. So you've got a conflict there between part over the building regs, which is trying to reduce down solar gain and reduce increased reflectance, so you get less solar energy coming in, and you've got a conflict with SAP, which is saying I'm interested still about heating, because SAP is really dominated, and part L is all dominated by have you got heating. So if you haven't got heating, say in a, I don't know, in a farmer's shed, you don't have to do the part L calcs for the energy. You still have to meet minimum standards, but you don't do the energy calcs because it hasn't got any heating. The other thing that's an absolute killer in domestic is thermal bridges. And thermal bridges are an absolute killer because you have to calculate everything and you have to put this all in manually. And most of the calculations and most of the fabric performance levels, the notional building's got a super high performance. And one of the biggest problems is that people are still not really waking up to the need for these. It needs to be calculated. Contractors are really struggling with it. And what you're going to find is there's a ticking time bomb with the new regs, which is building will fail because their thermal bridges were not up to the right levels. And there's nowhere else you can go because you can't get the fabric energy efficiency to pass without super duper fabric and junction performances. And the only way you can prove it is to rip the building down and start again, or to build the junction. So yeah, I haven't got more, if I only had more time to run through that, but yeah, ticking time bomb. EPCs, just finish off on there. So I've already alluded to a little bit about those. Same software, same calculations. As I mentioned earlier, there's rules you have to follow. There's no sort of flex with EPCs compared to Part L. These targets for EPCs, I was even slightly hesitant to put these numbers up there because these are theoretically going to be passed, but some of it is going through Parliament at the moment, and politics may well get in the way of this. These EPCs are being set to achieve for non-domestic a C by 2027 and a B for 2030. That's going to pick up the vast majority of buildings. Domestics are in theory going to be Cs over the next minimum of Cs, and this is for anything that is rented. So if you rent it, if you're an existing occupier, it's fine. So where's the ticking time bomb for this one is landlords. So landlords are going to be most interested in your EPC performance, because if they can't rent out their dwelling in their buildings because they haven't got the right EPC, they won't make their money. Where's the problem with that? The problem with that is in domestic, the way that you get a good EPC performance is a combination of good building fabric and good building services. And just to give you a feel, most of the new builds that we've done are generally Bs, a few are getting Cs, but generally it's sort of a B. Anything is existing, most houses are sort of typical houses are sort of, I don't know, built 60s, 70s, they're going to be Ds and Es. So anybody who's renting an older property is going to have a problem. And the problem with getting better EPC, and where we have a lot of problems with performance, is especially where you get a change of use. So an existing building was an office, now it's domestic. People don't want to spend the money on upgrading. But to get to your high performance levels, you've got to be upgrading your U values and your glazing to something akin to a new build to be getting anywhere close to the Bs and Cs target level. I haven't even put in the B level for domestic because I honestly don't know if it's ever going to come to fruition for politics. Same with non-domestic. Whereas the most sort of new buildings are getting sort of Bs. If you're in Wales now, it's a minimum to get a B, so it's only a matter of time before that being the English regs as well. But C by 2027, B by 2030. where we've found in running most of the calcs is the fabric isn't that big of an issue to get a better rating. It's much more in non-domestic, driven by which services you're selecting and what your usage profile is. Now that's a real problem for landlords, because if I'm a landlord, I can't rent out my building unless I've got a really good EPC. But my EPC is predominantly affected by what systems are being selected and used in there. And who is in control of that in a lot of rental properties? The tenant. So the tenant can't rent it from the landlord unless the landlord's got an EPC, but the landlord's EPC isn't entirely based on what the tenant has put in there. So it's a little bit of a catch-22. And of course, landlords don't want to completely impose onto their tenants how to fit things out. So once again, you are going to get a lot of spaces that can perform very varied. So we've done EPCs on buildings, sort of, I don't know, typical office, couple of floors, 3 or 4 retail units at the bottom, and they've performed anywhere between a D and an A. So it's not the landlord's fault of those performances, it comes down to what's installed. And moreover, the area, the types of spaces, the more services that you put in, the better the EPC performance, which is sort of a slightly sort of contradictory there. What it's asking for, in theory, it makes sense, because what you're saying is, I need a better heating system or a more efficient equipment system to show that compared to what is in the EPC, which is based on a reference building, which is sort of slightly more based on 1990s type building design, I guess, rather than the sort of the notional building for Part L. So there's sort of assumptions about lighting being more manual and stuff like that. You're going to find that the EPC performance varies quite a lot, and to the point where one of the solutions to get EPCs to perform better is to put in more equipment and more systems. So it's unlike a DEC, a display energy certificate, which is actually another form of energy calculation, but it's really much more simplistic. It's just simply based on 12 months of billing data, and you tend to only see them on publicly occupied buildings over 1,000 meters squared typically. An EPC is a prediction of a typical energy performance, not the actual building performance, a typical performance compared to a reference building. So if you chuck in loads of systems, you might make it work well. But I've been into retails where there's virtually no energy use being used, because they've got really simple lights. They don't really turn anything on. They might have an electric heater that they never turn on, because, you know, you can imagine an efficient chip shop is virtually self-heating. But the more systems you've got in there, the more ability you have to be able to show, well, look, my energy efficient is better compared to this baseline. So bizarrely, we may end up in a situation of landlords having to put more equipment in for their tenants that the tenants don't use, which is a little bit of a grey area. Is that environmentally a good thing to do or not? So yeah, some exciting challenges, and I guess that kind of comes on to my last thing really, which is sort of the future. Certainly, I think in terms of Part L compliance and EPCs is driving towards all electric systems. I think that's where the net zero carbon strategy is going. So we're going to all be moving away from gas over a period of time. That's going to be a particularly real challenge for Resi, where so many people have gas boilers and combi boilers. But overall, these targets are only going to get more onerous, but we are probably reaching the limit of what we can do in terms of fabric, and beyond that, eventually we will be getting into a balance between whether it be operational calculations or Part L. There's always going to be a place for Part L calcs, even if people do talk a lot about CIBSE TM54 and operational energy studies and that being more accurate, because it covers all parts. It's a consistent document, and therefore planning, policy and building regs, it gives you a consistency where the operational energy studies and TM54s and neighbours, there's a bit of subjective flexibility and economy of the truth in terms of what I'm using and what I'm not. So it's wherever you've got more rules and more flexibility, you're going to find navigation. So Part L is going to be around for a good while to come, and it gives the industry at least a standard that it can follow. So that's it from me. I'll hand over with a quarter of an hour to go with any questions.
just a reminder to everyone to post some of the questions. I do personally have few of mine, so I write them now and I will read them out loud. But in the meantime, if there's any burning question, please feel free to post in the chat, and we will basically read it out. So one of the question will be about the SBEM and SAP model for residential flats or buildings, where you mention it that if the corridor is residential block and it's heated, then SAP calcs are not sufficient because they are just covering the flat kind of peak load and heat losses. And therefore we will need to carry out like the SBEM calcs. Would that cover only the corridor or communal heated area, or we will need to do example of flat including that communal area, or it will be two separate small model like SAP for flats and all the communal spaces which are heated by SBEM or TAS, IS?
Second one. So you only run it on the non-occupied, the non-dwelling areas. And what's interesting is SBEM, because it gets, or the dynamic non-domestic, it gets done on a room by room basis. So you could run an SBEM on literally one corridor. So Part L kicks in as soon as it's got heating. The bizarre thing as well is if it's unheated, one of the other problems with SAP is that if that corridor is unheated, even though many projects that we have problems with corridor overheating, you actually, in theory, it's supposed to be a heat loss to that wall, so rather than a heat gain. So you have to start, unless you've got heating in the corridors, you actually start to have to consider its U value, and that can be missed by people. And then before you know it, you've got a 250 or 300 thick corridor wall where you wouldn't put that level of insulation in because it seems daft, and then all of a sudden your spaces get affected on the apartment size. So yeah, to answer your question, one model for the dwellings, or multiple for each dwelling, and then one for the non-domestic areas separated out in a separate model.
Yeah, it's become a bit more complicated, isn't it? Like just combine a few different we just combine report, but covers all the aspects. So the next one is relating to the rating, like all what you mentioned in some of the last slides, that dwellings need to be below C, and commercial actually from April this year it has to be less than E, so otherwise it cannot be lent. So basically SAP gives us like approximate kilowatt hours per meter square equivalent to rating. There's some like table like that to compare, and personally a lot of clients ask us like how we achieve the C, and usually the fees are quite low. We cannot just do all the models in SAP because it's extremely time consuming. Would you apply that kilowatt hours per meter square rule as a like kind of indicative solution, saying to client it's C or B, or you will more likely recommend to do SAP or SBEM model, in that sense that basically we quite often have actual data, so we always came up with higher kilowatt hours per meter square, and almost always we cannot achieve the rating C, let's say that way, without fabric improvement, massive improvement, especially when we are talking about building from the 80s, 90s, poor thermal performance and things like that.
Yeah, I've been running SAP since it first came out in sort of 2006, and I've never found a way that you can do and associate it with kilowatt hours, because that number, or that sort of letter that comes out on the back of the number, is a sort of relative calculation compared to between the two buildings. No, it's a simple answer. I've not found a magic tool to be able to say to a landlord or a tenant energy use intensity, which is obviously where some sort of like Letty is going down a route of, which I think is a very sensible route. No, there is no stand. Really, the only way to quantify if you think you're in the right ballpark is to look at the new build standards and say, are we anywhere near those? If you've got those, or pretty much most new builds are coming out as Bs. And I think that's a really good rule of thumb to see, am I going to be anywhere near an EPC rating that's decent?
I guess, yeah, as you say, OLED is, but obviously it's just the guidance. It's not still a standard, and it's mainly for the London area, but at least it's like starting point somewhere else, just to be around that bit. Maybe from someone else. So there's like office non-domestic national building for office doesn't not show any cooling demand and a high demand of domestic hot water, where domestic hot water is limited demand. Is that a cause? The model is only for heating? I don't know if you can see.
The models take consideration of heating, hot water, lighting, ventilation. Those are really the main things, and so hot water is in there. Interestingly, the older regulations, it's between the current regs and the previous regs, the way that the calculation methodology for hot water has changed slightly. It always used to be linked to whatever your heating system was. They've now separated that out. But in really simple terms, there's a table. If you're really interested in about how the hot water works, there's two things to be aware of. One is that the hot water allocation to your building and the notional building is based on the floor area of the occupied spaces. So even if you've got a big toilet area, it's actually how much hot water use will be calculated on, okay, I've got offices that cover 200 meters squared or 400 meters squared. That will be what the calculation for the hot water is on. The second thing is that there's a big onus now on circulation losses. So I don't think I'm quite answering the question, but it's the best answer I can kind of give. When you're calculating hot water and looking at what the estimation of hot water is in the part-L calculations, if you can go down to a small storage instantaneous electric system, often that seems to perform quite well, or as good as an air source heat pump served hot water system, because what you gain with the efficiencies of the air source heat pump, you lose the circulation. So there are rules about circulation and the pipe work, and obviously with pumping water around at 50 degrees, 60 degrees, whatever, that's also got a heat loss. So it's easy to forget when you size pipe work, you actually size it not only on the demand for water, you actually size it on the heat loss, on the return flow of that pipe work. So hot water is challenging in an office, and the daftest thing is you can't control it. So if you know no one washes their hands and they go in and they have a wee and they come out and they don't wash their hands, like lots of naughty people do, that's irrelevant. It's about what the national calculation methodology says will do that. And you can go into the other point, was in the national calculation methodology, there's tables, I think it's 8 to 10, and it will tell you all about the assumptions about hot water, that you can have a look in there and you'll find out some answers on that. So you can just download it, Google it, and you'll find the answers about hot water.
All right, we have one or maybe two more. On the different levels of modeling, what are your views on using RDSAP for homes built since 2008, when a SAP calculation has already been completed? I have seen a number of cases where a home rating has fallen from an expired on construction, some when new RDSAP has been completed. Should there be a lineage of data that allows the more detailed information needed in full SAP to be retained for future RDSAP estimation?
Yeah, I'm not a qualified RDSAP assessor, but it would be very, very sensible if the legal requirements are, I think you're supposed to retain the information for 10 years. So if it's EPCs last for 10 years, so if it's 10 years gone, then maybe or may not be a chance that the previous person, and you can find their details by downloading the older EPCs that were for that dwelling or that property. They contact them and they may have that data. If you get that, you can provide that to the EPC assessor. One of the reasons, and there is going to be a change with SAPs and RDSAP, is one of the reasons you would use RDSAP is where there is something you can't fairly reflect. Sorry, you use SAP where you can't fairly reflect the actual performance using RDSAP. Now, I'm not an expert in this, but I got told things like air pressure tests you can't use in there in the RDSAP. So therefore, if you know what the air pressure test of the building is, and you've got fabric detail, it may be worth having a conversation with someone who does SAP rather than RDSAP to get that result, because you might get better. The only experience I've had of conflict between SAP and RDSAP is actually we ran a SAP calc, we put in all the right data, and then there was an RDSAP done by one of the tenants. They got someone in, and the result was better than our SAP using RDSAP. I can't possibly comment, but I wonder if it hadn't been done correctly. And there are occasions where with RDSAP, people who do them, you charge you 35 quid, 50 quid, and to be able to get in there, do the work, do it all calculated, justify your qualifications. I don't know how they can afford to do it, but I know that I've heard stories of RDSAPs with a combi boiler being put in as a condensing boiler, and they've completely, or there's a hot water tank and they've assumed that it's a combi. So I think maybe the mass market RDSAP delivery is not always quite what it should be. So there isn't the cost to spend that time. So yes, I would talk to your RDSAP assessor and see if they maybe could run a SAP assessment for you.
Yeah, I think we do have that time for last question. So basically, what is your view on fabric improvement, especially when it comes to windows replacement of the windows which are double glazed, but they are more like pre-2002, where U value can be around 3.3 according to standards. Usually that can be also around 2.2. And as you mentioned during your presentation, like going to U value from standard about 1.2 or that, it's quite challenging, quite often financially not feasible. Would you normally recommend replacing windows as like double glazed windows which are 20 years old to the modern one? And what would be reasonable U value as to assume, especially for refurbishment buildings?
I think if secondary, if you've got any sort of planning restrictions, then I'd definitely go secondary glazing. One of the issues about is how do you justify what that U value figure is, the combined figure. But I would definitely go secondary if you can't take them out. If you can take them out, with my embodied carbon calculation hat on, I'd say don't take them out because of the negative environmental impact of it. But from an energy perspective, I'd say do take them out, and I would go as low as you can. I would go 1 point. I wouldn't get out of bed for less than 1 point, a U value of 1.4. And really, the challenge is that if you see these new standards, it's really pushing you towards triple glazing. Now, there's a knock-on with triple glazing because triple glazing is heavier than double glazing. So if you're especially doing new build, it's easy to forget that actual fact things get knock-on, like the density of the wall has to go up higher to be able to be strong enough to hold the glass. So that means your U value of your wall goes down. So you have to keep an eye on all of those little sort of knock-ons and interactions. But one thing that I came across the other day that I think is sort of maybe the great hope for the future is evacuated glazing. So that's seeming to being achieving a U value similar to triple glazing, but is effectively a double glazed unit with a similar weight. So it's used in conservation windows at the moment, but it's probably, and I haven't looked into the details, it's probably hideously expensive. So if you want to go with a really good double glazed, I'd be talking to someone about 1.4. And I think even when I had my changed at home, we got 1.4 with a guy who really didn't have a huge amount of idea about U values, but he could purchase them relatively straightforward. Want to go to 1 point, if you're really trying to get things to pass 1.2, 1.1, it's all possible. But you've got to have a manufacturer and a glazing that you actually understood. So yeah, one simple answer to your question, and I'd go for 1.4 if you can.
Perfect. Yeah, we are running out of time, I think.
Yeah, I think that's pretty much it. I think we've run out of time for today, but yeah, just ending off, I'd just like to say thank you for everyone for joining today. Obviously, thank you very much to our presenter, Matthew, for taking the time and to share his knowledge and preparing the presentation for us. Matthew has said that we can circulate the CPD slides, which we'll try and circulate in the course of next week. CIBSE will issue a certificate of attendance to all attendees. Matt also mentioned any further questions that you guys may have, you can just message him directly on LinkedIn. And then in closing off, just thank you all and wish you well. And we look forward to seeing you at the next CPD. Thank you very much. Cheers.
Thanks, everyone.
Thank you. Bye.